Welcome to Lesson 4, Decision, Topic 2. In this video, we're going to see how we can apply decision making to the Circuit Playground Express by retrieving information from the Circuit Playground Express and then doing something with it. In this video, we're going to see that the components pretty much lie in two categories. Some components are input components and others are output. So let's get to it. All right, so we got a basic template here where we got the library in here, we got Circuit Playground begin. Let's go ahead and create a variable for, let's say, our left button. And as we know, in our loop, we want to retrieve the value of that left button from the Circuit Playground Express. So let's do that, left button. And just as review, let's do a quick serial print just to investigate what we're getting with that left button. Oops, helps to actually put the variable in there. All right, so let's go ahead and upload it. And I have my serial monitor right here. And you can see that it's 0 right now. Let me pull up the camera as well. And remember, in order to orient this properly, the micro USB cable should be at the top. So I'm going to go ahead and press the left button and let's see what happens. We see that we got the value of 1, 0, 1, 0. Okay, so that was just a review of the kind of values we get from the left button. Now, combining that with an if statement, we can do something. For instance, maybe we could turn on some lights. So if the left button is equal to 1, that means that the user has pressed it. So let's go ahead and turn on, let's say, a couple of neopixels. So let's say set pixel color of, let's say, 0, and let's turn them red. I mean, obviously, you get creative. It doesn't have to be all the same color. I'm going to keep it simple for myself. Oops, let's go bring that down to the next line. And what I'm demonstrating here too as well is that an if statement can execute several statements when the condition is true. It doesn't necessarily have to be just one statement. And they don't have to necessarily be the same statement. I could add a playtone in here, but I'm not going to. Because as we've seen from previous videos, the playtone can be a little annoying, especially because in order to shut it down, you have to either disconnect it or load up a blank program. All right, so let's try this out. Let's upload it. Let's pull up the serial monitor. Let's pull up the camera. And we can see here none of the lights are turned on. And now when I press the left button, the lights turn on. But what you'll notice too is the lights stay on. It'd be nice for them not to stay on when the button is not pressed. So let's handle that real quick. And as we saw, an if statement has an additional statement that can be added called the else, which is if the condition isn't true, if our question doesn't result in a yes, i.e. in this case, is the left button pressed, then do this statement. Now, an easy way to kind of turn off all the neopixels is to use the clear pixels command. It will simply clear them all out, make them all zeros. So let's load that one up and check it out. Let's pull up the serial monitor. Let's pull up the camera. And as we can see here, nothing's turned on. I'm going to press the left button. The lights turn on. I'm going to let go of the left button. Now, if you're looking at the serial monitor, notice how the values of LB is 1. When I let go of it, the value of LB is 0. Hence, the condition is not being met. All right. So again, that's not an error. Some students typically will say, oh, the if statement doesn't work. I don't want to say it like that. The if statement's working. It's just that the condition is not being met, which lands you into the else part. So let's do it again. Press the button. LB is equal to 1, as you can see in the serial monitor, which means the lights turn on. I'm gonna let go of it, LB is equal to 0, which means we go to the else statement, clearing out all the pixels. All right, so that's how the button works. Hopefully I don't need to show you how the right button works. Works the same way. And the slide switch also works the same way, where to the left is one value, to the right is another value. I always forget which one it is, but that's why it's important to do a serial print. Again, you got to understand the type of input you're getting. So what I want to do now is I want to move on to a different type of sensor. So let's check out the light sensor. And for this, I'm going to put light, and the correct function name for this is light sensor. And I'm just simply going to comment out this little bit of code. So I don't believe this was discussed in a previous video. The /* starts what's called a multi-line comment. And then an */ ends a multi-line comment. Now notice how it all turns gray. What this does is that this tells the computer to ignore that. Again, that's one technique. Comments are really meant to, as you see here, to leave notes for somebody reading your code. But I like to use it to kind of, exclude some code from something I'm working on. So as we did before with the left button, let's just investigate to see what kind of values we're getting from the light. So let's go ahead and run this. Let's pull up the serial monitor. Let's pull up the camera. And you see here, we're getting values about 23. Now, if you recall, the light sensor is just above the left button. So I'm going to start, actually, you can even see as I start moving my finger over it, the numbers are going down, meaning it's the intensity of light. To the point that if I actually kind of like put my finger on it, I wonder if I can cut the whole thing. Can I get it to 0? I guess there's still light being seeped in through my hand. But the important thing to note with this particular sensor, this particular component, is that it's not a fixed value like the left button. You're not getting a 0 or 1, you're getting a range of values. And that's going to be important when we structure our decision, in that we can't hit a particular number. We're going to want to hit a general range, a threshold that has to be kind of crossed in order for the decision to work. So one of the cool things we could do with this is that, if it's dark, we could turn the lights on. If there's enough light in the room, we turn the lights off. And you might have seen things like this, out in the real world, these eco-friendly lights that turn on by themselves when it's dark and turn themselves off when there's enough light. So let's modify our if statement that we use for the left button to be if the light level is less than 10. Again, that seems to be an acceptable value right now for the light. Then we're going to turn the lights on. Now again, this is something you have to play with. It happens to be that I'm in a very dark room, even though it looks lit. The values of the light sensor can get up to about 1,000. So, to have a starting value of 20 means you're in a very dimly lit room. So let's go ahead and run this. Let me pull up the serial monitor. Let me pull up the camera. And you can see here that the lights are pretty, the number's pretty low. So I'm actually going to stand up and turn off the lights in my room. And you can see I just turned off the lamp that's on my desk, lowered down a little bit. Now let me actually turn off the lights. Actually, you kind of saw when I crossed in front of it, but I want to get you this feel of it. Okay, this is the room without the lights on. So notice the lights turn on. Now, turn the lights back on, the NeoPixels turn off. All right, so that is really cool. You kind of think that the circuit playground now is intelligent. It knows when to turn on the lights. Turns on the lights when the room is dark. Now, I've focused on pretty much just 2 sensors. Actually, I guess I got to bring up the camera again. There's a lot of other sensors. The right button, the slide switch, all have this 1-0 type of notion, whereas the light, I said the left button, the right button, the slide switch have this notion of a 1 and a 0. in terms of their values, where the light, the temperature, the sound, the capacitive touch pads, they all have a range of values. So you'll most likely end up using this type of an if statement to check to see if somebody has interacted with that particular sensor. All right. So let's go back to our presentation and let's review what we've done. So we continued our exploration of decisions, but this time we focused on the Circuit Playground Express. We saw that, you know, the left button, right button slide switches return values of 1 and 0, where the light, the temperature, the sound sensor, the recapacitive touches return a range of values. All of these components I just mentioned are input components. They're ways that we could get information from our environment into our program. Now, our only two means of output, as was mentioned early on, is our neopixels. So we can do something with the neopixels to convey information out. We could also use the play tone, but again, that's a little bit of an annoying component to work with, but realize it is there. So for instance, you could do something with like the temperature, where if the temperature gets too high, you can sound an alarm. And I think that would be very appropriate. If you think of the accelerometer is another good input component that also ranges in values. Again, if for some reason the circuit playground should tilt, fall, you can also sound an alarm. Maybe you could attach this to a machine, a statue, where it will let somebody know, hey, something's happening to the statue because it's not in the upright position. So hopefully you're excited. Decisions definitely empower you to do a lot with the circuit playground. The only limitation is your creativity. Enjoy.